We thought we knew what the universe looked like at the very beginning. Small, chaotic, just starting to exist. But something just showed up that completely breaks that picture. The James Webb Space Telescope has gone deeper than ever before. So deep, it's capturing light from objects that existed just over 100 million years after the Big Bang. Basically, the universe as a newborn. And yet, something is wrong. Astronomers expected faint, messy beginnings. Instead, they found massive, fully formed galaxies, structures that look like they've already lived for billions of years. So here's the question. Did the universe evolve impossibly fast? Or are we looking at something older than the Big Bang itself?
The discovery that's shaking astronomy right now is simple, but deeply unsettling. The earliest galaxies we can see don't look early at all. According to everything we thought we knew about the Big Bang Theory, the universe started small, hot, and chaotic. Over time, matter slowly gathered under gravity, forming stars, then galaxies, then clusters. That process takes time, a lot of time. But the galaxies JWST is detecting seem to ignore that rule completely. Astronomers using deep infrared observations have identified galaxy candidates like F2000DB-045, dating back to roughly 168 million years after the Big Bang. That's not just early, it's extremely early. At that stage, galaxies shouldn't even be fully assembled yet. They should be messy clouds of gas, just beginning to light up with the first stars. Instead, these objects appear bright, massive, and surprisingly structured. Now, here's how scientists know this. JWST doesn't just take pictures, it analyzes ancient light. Because the universe is expanding, light from distant galaxies stretches into infrared wavelengths, a process called redshift. By measuring that redshift, astronomers can estimate how far away a galaxy is, and therefore how far back in time it existed. But that's where the problem begins. When scientists analyze the brightness and color of these galaxies, the data suggests large amounts of stars, far more than expected for such an early time. In simple terms, these galaxies look like they've already gone through a long period of growth. And that directly conflicts with the lambda CDM model, which predicts a gradual, step-by-step formation of structure. So what's going on? Some researchers argue that these galaxies might only appear massive because of unusual star populations or intense bursts of star formation. Others believe we may be underestimating how quickly matter could clump together in the early universe. But here's the catch. Even with those adjustments, the gap is still too big. It's like expecting to find a newborn, and instead finding a fully grown adult. Which leads to a much more uncomfortable possibility. Maybe the timeline itself isn't as simple as we thought. To really understand how serious this problem is, you have to realize something most people overlook. We don't actually see the whole universe. Everything we observe exists within a limited region called the observable universe. It's essentially a cosmic bubble. Everything whose light has had enough time to reach us since the beginning of expansion. But beyond that bubble, there's more, a lot more. And here's where things get even stranger. The universe isn't just expanding, it's accelerating. Space itself is stretching, and in some regions, it's stretching so fast that galaxies are effectively moving away from us faster than light. Not because they're breaking physics, but because space itself is expanding. This creates a boundary known as the Hubble sphere. Beyond this limit, light from distant regions will never reach us. Not eventually, not ever. Which means there are parts of the universe that are permanently invisible. Now think about what that implies. Everything we know about cosmic history is based on a limited view. We are trying to reconstruct the entire story of the universe while only seeing a fraction of it. And now, JWST is pushing right up against that boundary, showing us objects from the very edge of what's observable. But interpreting those objects is incredibly difficult. When scientists estimate the mass and age of these galaxies, they rely on models of how stars behave, how galaxies evolve, and how light travels through space. If any of those assumptions are slightly off, the conclusions can change dramatically. But here's the key point. Multiple observations are pointing in the same direction. For example, astronomers have also detected signs of massive black holes forming and merging just 700 million years after the Big Bang. That's far earlier than expected. These black holes should need much more time to grow. So now it's not just galaxies, it's black holes too. Everything seems to be happening faster than it should. And when different pieces of evidence start aligning like this, it becomes harder to dismiss them as coincidence. Instead, it raises a deeper question. What if the problem isn't just what we're seeing, but how we're understanding it? When data starts to contradict theory, science doesn't panic. It evolves. And right now, that evolution is happening in real time. One possibility is that the early universe was simply more efficient at forming structure than we thought. Maybe conditions were so dense and energetic that stars and galaxies formed at extreme speeds, compressing billions of years of evolution into a much shorter period. That would mean the Big Bang theory still holds, but our understanding of early physics needs an upgrade. Another possibility involves dark matter. Since it makes up most of the universe's mass, even small changes in how it behaves could dramatically affect how quickly galaxies form. If dark matter clumps faster or interacts differently than expected, it could explain why these massive structures appear so early. But then, there are the more radical ideas. Some scientists are starting to explore whether the universe might actually be older than we think. Not dramatically older, but older enough to allow more time for these galaxies to form. Others are questioning something even bigger. What if the Big Bang wasn't the true beginning? Instead of being the absolute start of everything, it might have been a transition, a phase change from a previous state of the universe. In that scenario, what we call the beginning is just the start of the observable phase, not the start of existence itself. Now, to be clear, these ideas are still speculative. They're not proven. But the fact that they're even being considered tells you how serious this situation is. Because for decades, the standard model worked incredibly well. It explained the cosmic microwave background, the distribution of galaxies, and the expansion of space. But now, with JWST, we're seeing deeper than ever before. And the deeper we look, the more complicated the story becomes. And that's what makes this moment so important. We're not just discovering new objects. We're discovering the limits of our understanding. What makes this discovery so powerful isn't just what it shows, it's what it challenges. The James Webb Space Telescope isn't just revealing distant galaxies. It's exposing gaps in the story we thought we understood. And that's where things get exciting. Because every time we push deeper into the universe, we don't just find answers, we find better questions. So here's the one that matters. Are we seeing the true beginning of everything, or just a small chapter of a much bigger story? Drop your thoughts in the comments. I'm genuinely curious. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel grow. Thank you for watching, and see you next time.